In this video, we're going to discuss CRA models for integer multiplication rules. Okay, so we're multiplying two integers, right? So these only apply if there's two. If there's multiple or more than two multipliers, then these will change. But when we're just multiplying two integers, so we might have some negative numbers, might not. The rules are if that the two multipliers have the same sign, so either both positive or both negative, our product will be positive. If our multipliers have different signs, so one negative and one positive, then our product will be negative. Okay, so we just have two different cases that we'll look at. We're going to show this. So we're going to start with the same sign rule. Okay, and I have, I'm just going to use arrays with the two color counters for all the concrete models for these. So if we have three groups of two, right, three groups of two or three rows that have a size of two, right, then my product is these six counters, right, these six yellow counters. So yellow is positive, so my answer is going to be 6 here. When I have two negative signs, right, first we're kind of how we're interpreting this as we're showing this as three groups with the size of -2, so three rows with the size of -2. But since I have that negative at the front, I want the opposite of three groups of -2. Okay, so I'll need to do the opposite or take the opposite side of these. Okay, to find that I have 6 yellow counters. Okay, so both of these, right, they both had the same sign. They both ended up being positive. Okay, so it's a little more clear for the positive 3 times positive 2 case why that will be positive. But kind of a rationale for why this will always be when we're multiplying two negative numbers is, again, if we're starting with this interpretation as three groups of -2, we're always going to be starting on the negative side. We're always going to be starting with this negative product shown, and then we always have to take the opposite, so we always have to flip it to the positive side. So always start with the negative and flip it to the positive. So it doesn't matter what the numbers are, whether it's 7, 25, whatever. We'll always start with the negative, flip it to the positive. So that's why this rule will always be positive for either. Okay. Then we'll show a representational model. We'll just do number lines for those. Okay, so for 3 times 2, right, it's just going to be three groups of +2 to get to 6. I'll have to draw a little bit larger number line for this one, because again, we're always going to be, right, three groups of -2, but we want the opposite of this, the opposite of -6, which will get us to +6. Okay, so for both we ended up at +6 since we had the same sign. And again, the reasoning for this, right, for the 3 times 2, there's no way we can move in the negative direction for anything. We don't need to go to the opposite side or have negative quantity, so we'll always be positive. For -3 times -2, we'll always be starting by going in that negative direction, so we have some negative quantity, and then we always want the opposite of that. We always want the opposite of some negative, which will always be some positive. Okay, so that's the representational model. And then the abstract model for the 3 times 2, all right, it's just 3 times 2 equals 6. Really kind of what we're doing here for this -3 times -2, right, kind of the shorthand. Right, if we know this is going to be positive, what we're essentially doing is just changing this into 3 times 2. Kind of the longer format, why we're able to do this is if we factor a -1 out of 3 and factor a -1 out of 2, right, we get -1 times -1 times 3 times 2. So we have this 3 times 2, so we get 6. Then if we multiply by one of the -1s, that's -6, and multiply by another -1, that's going to be +6. Right, so this -1 times -1 piece simplifies to just be 1, which is why we don't necessarily need to write it in this expression, because that's the identity property multiplication. All right, so that is the same sign. And then we'll look at the different sign rule, so it kind of explaining why this will always be negative. So again, I have the easier case shown on the left. Right, so here we have 3 groups that have a size of -2, so 3 rows with a size of -2. So you can see there's a total of 6 red counters, so -6. So that will always be negative because the group size is negative. Okay, we have however many groups we have, all those groups will have a negative size, so that total has to be negative. And then again here, how we're starting to look at this is we're kind of ignoring the opposite piece right away. So we're just looking at 3 times 2, so 3 groups of 2, 3 rows of 2. So this is a model for 3 rows of 2, 3 times 2. We want the opposite of that, so we need to switch this to the opposite side. So we'll also get a -6 over here. Okay. So again, in this case, the reason this is always negative is because the groups always have a size that's negative. Right? It's a positive number of groups. It's not the opposite of some groups. It's just those groups with a negative size. Over here, we'll always be starting with a group size that's positive, but we always want the opposite of that since that first multiplier is negative. So we'll always have to flip this to the opposite side, which will always be to negative. Okay. So that's the concrete models, that different sign rule. For representational, for 3 groups of -2, again, we'll always have groups in the negative direction here since the second multiplier is negative. So we always have to end up somewhere to the left of 0 on the number line. And then for this case, right, we'll always start out by, since we have a positive group size, we'll start out by thinking of this as just 3 groups of that positive amount, 3 groups of 6. But then since we have the leading negative, we'll always want the opposite of this. So we'll always have to go to the opposite side of 0 on the number line. So no matter what, we'll always end up on that negative portion on that left side. Okay. And then essentially what we're doing with this for the abstract model for either of these, we're just saying we know this is going to be negative, and we're just thinking of what the product is going to be. So what we're essentially doing is just factoring that negative out. We know that it's going to be a negative product. Same with our -3 times +2. Right, so these will actually end up looking the same. Right, we're just factoring that negative out. We know we'll apply that later. We get -1 times 6, so both of these are going to be -6. Okay. So those are the 2 rules. Right? Same sign is positive, different sign is negative, and then the 2 color counters and the number lines, and then our equations will be our models there.